Welcome back. We are finishing up our calculations on this combination circuit. So, quick recap, we've solved for our total current, our total resistance, and this was our combination resistance for those parallel portions of our circuit. So what we're going to find next is the voltage across each parallel circuit. Each series circuit. Because remember, the voltage across the series portions is different. So remember, voltage is equal to current times resistance. And I'm going to find the voltage across this first portion of my circuit. My resistance is going to be the combination resistance we found for R1 and R2. And my current is going to be the total current. So we'll call that V1. And that's going to be my total current times that combination resistance of those two. And I have that copied here. We did find that earlier. So that's going to be 0.121 times 71.429. And that gives me about 8.6275 volts. And we're going to do the same thing for V2. Still my total current, but this time I'm using that combination of resistors 3 and 4. So 0.121 times 127.27 gives me about 15.373 volts. Now remember, the sum of those two volts should equal my total voltage 24. So let's verify that. And that does equal approximately 24 volts, so we have verified that. So now we are going to find the current across each individual resistor. So first we're going to find I1 and I2. Now remember, if we rewrite Ohm's law to solve for current, that's our voltage divided by resistance. And we just solved for the voltage across resistors 1 and 2. So that is going to be V1 divided by resistance 1 to find I1. So that value was that 8.6275 divided by resistance 1 is 100 ohms. And so for I1, we get 0.086275 amps. And then we're going to do the same thing for current 2, but we're going to be using our resistor 2 value. Still V1, because that's the same voltage across resistor 2. Now the sum of I1 and I2 should be my total current. I total 0.121. So let's verify that in the calculator. And that does give me about 0.12 amps. Now we're going to do the same thing for I1 and I3, but the voltage 2 is what the voltage is across both of those resistors. So to find I3, we're going to use voltage 2 divided by resistance 3. Remember, voltage 2 was this value up here. And our resistance 3 is 350. And so that gives me approximately 0.0439 amps. And then for current 4, we're still going to use this V2 because that's the same voltage across resistor 4, and we're using the resistance from resistor 4. And that gives us 0.0769 amps. And again, our total current should equal the sum of these two values. And that is 0.121 amps. So we have confirmed that. And that is all of our calculations for this combination circuit.